In this unit of the course, I also wanted to demonstrate how to construct amortization schedules. Fits along quite nicely with the topic of the time value of money. Amortization schedules can be really helpful, and they will make your life so much better as you navigate accounting and finance courses in the future if you're good at constructing them. Usually, we think of these in the context of fully amortizing loans. They are useful presentation tools, typically consisting of 6 columns that tell you for any given period what is the carrying value for a given asset or liability. For amortizing loans, this obviously refers to the liability side, right? You want to be able to say that at the beginning of the period, what is that loan's balance? And after I've made a payment, what is the new outstanding balance? Part of the trick here is realizing that the carrying values of these types of loans do not decrease strictly by the amount of the payment. Amortization schedules will also break payments into their interest and principal components. And in the end, they're just good organizational tools. In the future, when you're doing accounting homework and intermediate financial accounting, you're going to want to be able to whip one of these out in your sleep because each line of the schedule will be your answers to constructing journal entries. It'll help you know what goes on the balance sheet. Your intermediate financial instructor may or may not spend time in class to help walk you through this process, but textbooks will display these, and it will be very useful when you work on homework. Additionally, you will find times in your life when creating an amortization schedule can help form your own personal finance decisions. In our Excel file, our 2 exercises will focus on personal finance applications. On the first amortization schedule sheet, you'll notice that it's already been done for you. This is referencing cells from the prior sheet, thus presenting how your hypothetical mortgage loan will amortize over time. I'm going to walk through each of these columns, then we'll build the same exact schedule from scratch again, and then I'll have you try to build one on your own in the next sheet. The period column represents each payment period of the asset or liability. Now often we're going to be talking about loans, but you can also construct an amortization schedule for assets, like investments. The periods in question could be monthly, semi-annually, or annually, depending on the situation. For most loans, like mortgages, payments will be made monthly, so each period represents a new month. The beginning balance column shows the outstanding loan balance at the start of each period. For the first period, this is going to be the initial amount borrowed. As you make payments, this balance will decrease over time. The payment column indicates the total payment made each period. This payment is typically a fixed amount that covers both the interest and a portion of the principal balance. It remains constant throughout the loan term. The interest column shows the portion of the payment that goes towards interest for the period. The interest amount is calculated by multiplying the beginning balance by the interest rate as adjusted for the correct unit of time. In this case, we would have taken $485,000 times 6.5% divided by 12. Remember, interest is the cost of borrowing capital. Earlier in the loan, a larger portion of the payment will go towards interest. The principal column represents the portion of the payment that goes towards reducing the loan's principal balance. The ending balance then shows the remaining loan balance after each payment. It is calculated by subtracting the principal portion of the payment from the beginning balance. This ending balance then becomes the beginning balance of the next period. So what does our schedule look like here? We start off, period 0, we haven't made any payments yet. This was our original loan amount, $485,000, which becomes the beginning balance in period 1. Here is our fixed payment, a portion of interest and principal, and then we get the ending balance by subtracting $438 from $485,000. In period 12 here, this will be at the end of the first year of our mortgage, and even at this point, the interest component is going to be more than 5 times the amount of our principal reduction. As we scroll down, keep noticing the payment is still constant. This is a fixed payment. And as time goes on, the interest component shrinks, the principal part grows. Let's go down to the very bottom. The ending balance of our loan at the end of period 360, after our last payment, the balance is 0. This is a pretty good check to make sure we've constructed this correctly. The last number should be what we expect it to be. Let's now delete everything up through row 4. even the column headers, because I want you to practice constructing an amortization schedule from scratch. So please follow along here. You're going to want to be able to demonstrate your mastery of this by doing it on your own in the next sheet, and who knows, I might ask you to replicate this process on an exam setting. So let's start in cell B4 by typing the word period. This will indicate when a given payment is made within the life of the loan. Next comes the beginning balance. Where does our loan start at? Then payment, the fixed amount we pay each month. And we know our payment can be broken down into two components, interest and principal. Interest is calculated as the cost of financing our current outstanding balance, and principal is the remainder, the amount by which we decrease how much we owe. After subtracting this amount in column C, we get our ending balance. Getting the column name set up correctly is the first step. Now we need to fill it in. I like to start by putting an ending balance amount in a period 0. It's not strictly necessary, but it's going to be helpful for the sake of our cell referencing. And at any rate, textbooks will often present items this way. So nothing happens during period 0, so I can either type in the ending balance or make a reference to the loan amount from above. Let's input a value for period 1. And before proceeding with the rest of the figures in this period, I like to use the fill handle to pre-build the total number of periods in question. When we're creating a numeric series with just one column, Excel will let us preview the numbers off to the side, and it will help us know once we've hit the number 360. Okay, so back to period 1. For our beginning balance, I want to reference the ending balance we just created in cell G5. That way, when I copy this formula down, the beginning balance of one period will always equal the ending balance of the prior period. Next, the payment. I brought in our payment from the prior sheet in cell D2. Since our payment is fixed, we don't want this number to ever change in this table. So we've got a couple of options. I could just manually type in 3065.53, and when I would use the fill handle to copy the value of this cell, it wouldn't change. So that would be good. But if I want to quickly try a different set of assumptions, I will have to manually change it again. Remember, part of the beauty of Excel is the ability to reference and update automatically. So I'm actually going to reference cell D2. Importantly, I am going to hit F4 to make this an absolute reference. As I copy this formula down, I don't want my reference to change. The last 3 columns will involve calculations. Interest will equal the beginning balance times the adjusted monthly interest rate. Remember, with monthly payments, we need to divide our annual interest rate by 12. So I'll hit equals, make a relative reference to our beginning balance in cell C6 times, and again, you could hard code in an interest rate, but if I want to try out different rates quickly, I would prefer this to be an absolute reference to cell E2 above divided by 12. Principal will equal the payment minus the interest. This is the part of our payment that exceeds the interest amount, and it goes towards reducing the principal balance of the loan. We reflect this in our ending balance by taking our beginning balance minus principal. Okay, if we've done everything correctly, I can highlight all of these cells, double-click the fill handle, and it copies that down. As a very quick check figure, we go to the very bottom, control down, and there is our amount of 0. So, do you feel like you're ready to do this on your own? I've got another personal finance context to work with. You're considering the purchase of a car, and you're going to have to finance it with a 5-year loan. The car's purchase price is $30,000, but you will make a down payment of $5,000. The remaining amount will be financed with a loan with an interest rate that's annually at 5%, but compounds monthly. I give you the payment right here. We can reference it. It's $471. You can see what the TVM calc was. And I want you to construct an amortization schedule that shows the breakdown of each monthly payment, this $472 amount, into its principal and interest components, as well as updating the outstanding balance of the loan after each payment. Essentially, create an amortization schedule just like we've done before. As a quick warning, I want you to carefully think about what the beginning balance of the loan will be given the fact that there is a down payment. But at this point, pause the video and see if you can build this schedule from scratch. All right, let me give you my solution. The first thing we need to do is label some column headers here. I want to see what my 6 different columns are, and I can't just copy and paste this from the prior slide, but I hope this is something you can do from your head. You're going to be so familiar with this, you can do it in your sleep. So bear with me as I type period, beginning balance, payment, interest, principal, and ending balance. You know that I like to start with a period of 0 and an ending balance equal to the initial amount of the loan. Well, if the car's purchase price was 30 grand, but we make a down payment of $5,000, this is going to be $25,000. In period 1, the beginning balance of the loan will equal the prior period's ending balance. For my payment, I'll make an absolute reference to cell I5. But now I need to break this into interest and principal. The interest component will be the beginning balance times the annual interest rate, 0.05, divided by 12 because it compounds monthly. The principal will be the remaining amount, payment minus interest. Lastly, we'll update our ending balance by taking the beginning balance and subtracting from it that portion of the payment that goes towards reducing the principal. I'm going to drag down this period line to make sure we get to 60 exactly. I think that's always helpful. And now I think I'm ready to double click the fill handle and see what we get. Okay, payment is fixed. That looks good. Interest is decreasing over time. That's what we want to see. And in my last payment, we hit a value of 0. So make some tweaks if you have to rework this, but if you got it on your first try, just know I'm giving you a pat on the back. Great job.